Picture this, a star so massive, so fiery that it burns through its life in a mere cosmic blink, racing toward a spectacular end that could light up our skies like a second moon. This is the story of Betelgeuse, a red supergiant in the constellation Orion, a celestial giant that has captivated astronomers and stargazers alike for centuries. But now, in 2025, a groundbreaking discovery has unveiled a new chapter in its saga, a faint companion star, a cosmic sidekick named Sawara, orbiting perilously close. This revelation not only solves long-standing mysteries about Betelgeuse, but also hints at a dramatic future where one star may consume the other. Buckle up as we dive into this stellar tale, exploring the science, the surprises, and the sheer wonder of a star that might just explode in our lifetime. Stick around until the end because this story is packed with twists, and we'd love for you to share your thoughts in the comments below. Let's start with the star itself. Betelgeuse, pronounced Beetlejuice. Yes, like the quirky movie character, is no ordinary star. It's a red supergiant, a behemoth roughly 1,000 times the diameter of our sun. If you plopped Betelgeuse at the center of our solar system, it would swallow Mercury, Venus, Earth, and Mars, stretching nearly to Jupiter's orbit. Located about 642 light-years away in Orion's shoulder, Betelgeuse is one of the brightest stars in our night sky, glowing with a fiery reddish hue that's impossible to miss. Its light, which takes over 6 centuries to reach us, tells a story of a star that's lived fast and is now teetering on the edge of its life. But what makes Betelgeuse so special? Unlike our sun, a stable, middle-aged star that will shine steadily for billions of years, Betelgeuse is a cosmic rebel. Massive stars like this one burn hotter and brighter, exhausting their fuel in just a few million years. And when they run out, they don't fade quietly. They explode in a supernova, a cataclysmic blast that can outshine entire galaxies for weeks. The idea of a star exploding so close to Earth is both thrilling and a little unnerving. Could Betelgeuse's end affect us? What would it look like? And why is it acting so strangely now? Let's unpack these questions, starting with a trip back in time to understand why supernovae matter. About 2.6 million years ago, a star just 150 light-years from Earth went supernova. The explosion was so powerful that scientists believe it may have showered our planet with cosmic rays, potentially contributing to a mass extinction event that wiped out many large marine animals. The remnants of that blast, now a faint nebula, remind us that supernovae are not just cosmic fireworks. They can reshape worlds. Fast forward to today, and our closest star, the Sun, poses no such threat. It's a stable, middle-of-the-road star that won't go supernova for another 5 billion years or so. But Betelgeuse? That's a different story. Stars like Betelgeuse, Spica, Antares, and Rigel are massive enough to end their lives in spectacular explosions. While these stars are nearby in astronomical terms, hundreds of light-years away, they're far enough that Earth would be safe from their blasts. If Betelgeuse went supernova tomorrow, its light would dazzle our skies, potentially outshining the moon for days or weeks, visible even in broad daylight. Imagine stepping outside to see a blazing star dominating the heavens, a once-in-a-lifetime spectacle. But here's the kicker. Because Betelgeuse is 642 light-years away, the light we see today left the star around the year 1383. If it exploded back then, the show could start any day now. No one knows exactly when, but recent discoveries suggest the clock is ticking faster than we thought. For years, Betelgeuse has been a puzzle, its brightness fluctuating in ways that baffled astronomers. But in late 2019 and early 2020, something extraordinary happened. The star dimmed dramatically, losing about 35% of its brightness. This event, dubbed the Great Dimming, was so striking that amateur stargazers noticed it with the naked eye. Stars don't just dim like that without a reason, and astronomers scrambled to understand why. Was Betelgeuse on the verge of exploding? Had something catastrophic happened? Using cutting-edge telescopes, including the European Southern Observatory's Very Large Telescope, scientists pieced together the answer. Betelgeuse had ejected a massive cloud of dust and gas from its surface, likely triggered by a violent upheaval in its outer layers. As this cloud cooled and drifted in front of the star, it blocked a significant portion of its light, creating the illusion of a dimmer star from Earth's perspective. It was like a cosmic curtain being drawn across Betelgeuse's fiery face. This discovery was a relief. Betelgeuse wasn't exploding yet, but it raised new questions. Why was the star ejecting so much material? Was this a sign of its impending doom? The Great Dimming wasn't the only clue Betelgeuse was dropping. Astronomers noticed another pattern, a rhythmic dimming and brightening that repeats every 400 days. This wasn't caused by dust clouds or external factors, it was coming from within. Red supergiants like Betelgeuse pulsate, their outer layers expanding and contracting like a slow cosmic heartbeat. As the star swells, it cools slightly and dims. As it shrinks, it heats up and brightens. This 400-day cycle is Betelgeuse's signature rhythm, a window into its turbulent interior. These pulsations are more than just a quirk, they're a glimpse into the star's soul. Massive stars like Betelgeuse are powered by nuclear fusion, but as they age, their cores become unstable, triggering these rhythmic expansions. Some astronomers believe that changes in a star's pulsation could signal it's nearing the end of its life. While Betelgeuse's 400-day cycle doesn't mean a supernova is imminent, it's a reminder that this star is in its final act. Every pulse is a whisper from its core, and scientists are listening closely, eager to predict what comes next. But the plot thickens. Alongside the Great Dimming and the 400-day pulsations, astronomers noticed a third type of dimming, one that occurs roughly every 6 years. This pattern was a head-scratcher. It didn't match the star's internal pulsations, nor was it caused by dust clouds. For years, this 6-year cycle remained a cosmic mystery, defying explanation. Then, a bold hypothesis emerged. What if Betelgeuse wasn't alone? What if a smaller companion star was orbiting it, periodically dimming its light as it passed in front of or interacted with the supergiant? This idea was tantalizing but hard to prove. Betelgeuse is so bright and massive that spotting a smaller, dimmer star nearby is like trying to see a firefly next to a spotlight. Computer models suggested that if a companion existed, it would be 1 to 2 times the mass of our sun in orbit at a distance of a few astronomical units, AU. For context, 1 AU is the distance between Earth and the sun, about 93 million miles. But detecting such a star required technology at the cutting edge of astronomy. In 2025, that technology delivered. Using the ALMA, Atacama Large Millimeter Submillimeter Array, and the Gemini North telescope in Hawaii, equipped with the advanced Alipec instrument, astronomers made a historic discovery, a faint companion star orbiting Betelgeuse. They named it Siwara, a nod to its elusive nature. Siwara is a pre-main sequence F-type star, roughly 1.6 times the mass of our sun, orbiting Betelgeuse at about 4 astronomical units, closer than Jupiter is to our sun. Its orbital period, 5.94 years, aligning almost perfectly with the mysterious 6-year dimming cycle. Siwara's discovery was a game changer. It explained the 6-year fluctuations. As Siwara orbits Betelgeuse, it likely interacts with the supergiant's extended atmosphere, causing subtle changes in the light we see from Earth. But Siwara itself is a fascinating enigma. Unlike Betelgeuse, which is nearing the end of its life, Siwara is a stellar infant, a pre-main sequence star that hasn't yet ignited nuclear fusion in its core. Born from the same cosmic cloud as Betelgeuse millions of years ago, these two stars couldn't be more different. Betelgeuse is a fiery giant burning through its fuel at breakneck speed, while Siwara is a slow starter still gathering itself for a stellar life that may never fully begin. The relationship between Betelgeuse and Siwara is more than just a cosmic curiosity. It's a doomed dance. Betelgeuse's immense gravity is slowly pulling Siwara closer, and astronomers predict a grim fate. Within the next 10,000 years, Betelgeuse may cannibalize its companion, absorbing Siwara's material into its fiery embrace. This act of stellar consumption could accelerate Betelgeuse's path to a supernova, a blast that would leave behind a neutron star or even a black hole. But before that happens, Siwara has one more moment in the spotlight. In November 2027, it will reach its maximum separation from Betelgeuse, offering astronomers a rare chance to study this faint companion in greater detail. Using next-generation telescopes and instruments, scientists hope to learn more about Siwara's composition, orbit, and the strange dynamics of this stellar duo. Every observation brings us closer to understanding how massive stars like Betelgeuse live, evolve, and meet their explosive ends. Zoom out for a moment and consider what Betelgeuse represents in the grand tapestry of the universe. Stars like this red supergiant are the universe's alchemists, forging heavy elements like carbon, oxygen, and iron in their fiery cores. When they go supernova, these elements are blasted into space, becoming the building blocks for new stars, planets, and even life itself. Every atom in your body was once born in the heart of a star like Betelgeuse, a reminder that we are all, quite literally, made of stardust. The discovery of Sawara adds a new layer to this story, showing how even the interactions between stars can shape the cosmic landscape. As Betelgeuse nears its end, it's not just a spectacle. It's a vital part of the cycle that creates and sustains the universe. Imagine the clouds of gas and dust from its eventual explosion drifting through space, perhaps one day forming a planet where new life gazes up at the stars, unaware of the ancient drama that made it possible. This is the legacy of Betelgeuse, and Sawara's fleeting presence only deepens the narrative. Why does Betelgeuse capture our imagination? It's not just the science, it's the story. For centuries, humans have looked to the stars for meaning, weaving myths and legends around constellations like Orion. Betelgeuse, with its fiery glow, has been a beacon for navigators, poets, and dreamers. Now, with Sawara's discovery, it becomes a symbol of the universe's complexity and beauty. A tale of two stars, one old and one young, locked in a dance that spans millions of years. This story resonates because it reminds us of our own fleeting existence, our own journeys through time. Just as Betelgeuse pulses and Sawara orbits, we too move through cycles of change, growth, and transformation. The stars invite us to wonder, to question, and to connect with something larger than ourselves. So the next time you step outside and spot Orion in the night sky, take a moment to find Betelgeuse's reddish glow. Think about Sawara hidden in its shadow and the cosmic drama unfolding light years away. As we look to the future, Betelgeuse keeps us on the edge of our seats. Astronomers estimate it could go supernova anytime within the next 100,000 years. A blink in cosmic time, but a lifetime for us. The presence of Sawara complicates the timeline, as its gravitational tug and eventual consumption could destabilize Betelgeuse's core, hastening the inevitable. Yet the uncertainty is part of the thrill. Will we witness the explosion in our lifetime? Will our descendants see it centuries from now? Every new observation, like the upcoming chance to study Sawara in November 2027, brings us closer to answering these questions. Telescopes like the James Webb Space Telescope and the upcoming Extremely Large Telescope are poised to capture unprecedented details, offering clues about Betelgeuse's final days. This waiting game is a testament to the patience and passion of astronomers, who dedicate their lives to unraveling the universe's secrets, one star at a time. Let's take a deeper dive into what makes Betelgeuse's impending supernova so fascinating, and why Sawara's presence adds such an intriguing twist. Inside Betelgeuse, a cosmic clock is ticking. As a red supergiant, it has already burned through its hydrogen fuel, moving on to heavier elements like helium, carbon, and oxygen in its core. Each stage of fusion is shorter and more intense, pushing the star closer to its breaking point. When Betelgeuse finally exhausts its fuel, its core will collapse in a fraction of a second, triggering a shockwave that rips the star apart in a supernova explosion. This process is inevitable, but Sawara's gravitational influence could be stirring the pot. By tugging on Betelgeuse's outer layers, Sawara may be accelerating the instabilities in its core, potentially shaving thousands of years off its lifespan. Imagine two dancers in a cosmic waltz, where one partner's steps are hastening the other's collapse. This dynamic interplay is a rare glimpse into the chaotic lives of massive stars, and it's why astronomers are so eager to study this pair. The data collected in 2027, when Sawara reaches its farthest point from Betelgeuse, could reveal whether this companion is indeed speeding up the supergiant's demise, making every observation a critical piece of the puzzle. The Betelgeuse-Sawara system is more than just a cosmic spectacle. It's a living laboratory for understanding stellar evolution. Stars are born, live, and die in cycles that span millions or billions of years, and each phase offers clues about the universe's past and future. Betelgeuse represents the twilight of a massive star's life. Its bloated, unstable form a stark contrast to Sawara's youthful inertia. This contrast is a perfect illustration of how stellar mass dictates destiny. Massive stars stars like Betelgeuse race through their lives, their intense gravity and heat driving rapid fusion that leads to a fiery end. Smaller stars like Sawara, on the other hand, take their time, lingering in their pre-main sequence phase for millions of years before igniting as true stars. But Sawara's proximity to Betelgeuse may rob it of that chance, pulling it into the supergiant's orbit and dooming it to an early demise. By studying this duo, astronomers are learning how binary star systems evolve, how their interactions shape their fates, and how these processes contribute to the cosmic ecosystem. Every pulse, every dimming, every orbit is a data point in a story that began millions of years ago and will echo for millennia to come. This is science at its most thrilling, a chance to witness the universe's machinery in action. Beyond the science, Betelgeuse holds a special place in human culture, and Sawara's discovery only amplifies its allure. For ancient civilizations, Orion was a hunter, a warrior, a god, and Betelgeuse was his blazing shoulder, a symbol of strength and mystery. Today it's a scientific marvel, but its cultural resonance remains. The possibility of Betelgeuse exploding in our lifetime has sparked fascination across the globe, inspiring artists, writers, and filmmakers to imagine what such an event would mean. Would it unite humanity in awe as we gather to watch a star's final act? Would it spark new myths for a modern age? Sawara's discovery adds a layer of tragedy to this narrative. A young star caught in the shadow of a dying giant, a reminder of the fleeting nature of existence. This story resonates with our own experiences of love, loss, and the passage of time. As we await Betelgeuse's next move, we're reminded that the universe is not just a collection of stars, but a stage for stories that connect us all. So, the next time you gaze at Orion, let Betelgeuse and Sawara inspire you to dream, to wonder, and to share in the timeless human quest to understand the cosmos. So what would happen if Betelgeuse went supernova in our lifetime? First, the good news, Earth is safe. At 642 light-years away, the explosion's radiation would pose no threat to our planet, but the spectacle would be unforgettable. For weeks, Betelgeuse could shine brighter than the moon, visible day and night, casting a surreal glow across the sky. It would be a global event, uniting people in awe of the universe's power. Scientists would be glued to their telescopes, capturing data that could rewrite our understanding of supernovae. The bad news, Sawara's days are numbered. If Betelgeuse explodes within the next 100,000 years, as astronomers predict, it will likely engulf its companion in the process. Sawara, still in its stellar infancy, may never get the chance to shine as a true star. This cosmic tragedy underscores the vast differences in stellar lifespans. Massive stars like Betelgeuse live fast and die young, while smaller stars like Sawara or our Sun take their time, evolving slowly over billions of years. The discovery of Sawara and the ongoing study of Betelgeuse are more than just scientific triumphs. They're a reminder of our place in the cosmos. Stars are the engines of the universe, forging the elements that make up our planet, our bodies, and everything we know. When a star like Betelgeuse goes supernova, it scatters those elements across space, seeding the raw materials for new stars, planets, and perhaps even life. By studying Betelgeuse and Sawara, we're piecing together the story of how the universe builds, destroys, and rebuilds itself. This tale also sparks the imagination. What does it mean to witness a star's final act? How does it feel to know that a cosmic event millions of years in the making could unfold in our skies? Betelgeuse's story is a call to look up, to marvel at the universe, and to share in the excitement of discovery. Whether it explodes tomorrow or in 1,000 years, Betelgeuse reminds us that the cosmos is alive, ever-changing, and full of surprises. The discovery of Sawara and the deepening understanding of Betelgeuse's behavior are testaments to human ingenuity and the relentless march of technology. Unraveling the mysteries of a star 642 light-years away is no small feat. It requires telescopes that can peer through the cosmic haze, instruments that can detect the faintest glimmers of light, and scientists who can interpret the whispers of the universe. The ALMA array in Chile, with its dozens of radio dishes working in unison, captured the subtle signals of Sawara's presence, while the Gemini North telescope in Hawaii, armed with the Alopeke instrument, provided the sharp imaging needed to confirm its orbit. These tools represent decades of innovation, from adaptive optics that correct for Earth's atmospheric distortion to millimeter wave observations that reveal hidden details invisible to optical telescopes. But it's not just about the hardware. Supercomputers crunching vast data sets, machine learning algorithms sifting through noise, and international collaborations pooling expertise these have all played a role. This technological triumph extends beyond Betelgeuse, offering a blueprint for studying other massive stars and their companions. As we approach November 2027, when Sawara reaches its maximum separation, the next generation of observatories, like the Square Kilometer Array and the Vera C. Rubin Observatory, will push the boundaries even further, capturing data that could redefine our understanding of stellar death. This blend of human curiosity and cutting-edge technology is what makes the Betelgeuse-Sawara saga so compelling, a reminder that our quest to explore the cosmos is as much about our tools as it is about our dreams. What do you think about Betelgeuse and Sawara's cosmic dance? Would you want to see a supernova light up the night sky? Drop your thoughts in the comments below. We'd love to hear from you. If this journey through the stars sparked your curiosity, give this video a thumbs up and share it with a friend who loves the universe as much as you do. Subscribe for more cosmic adventures where we'll keep exploring the wonders of the universe, one star at a time. Until next time, keep looking up.